Okay, here are the solutions to your practice problems for the day on using the division rules with exponents. So I'll get right into it. As always, pause, rewind. This is for you to understand, so make sure you do, and there'll be more. Taking this a little bit further tomorrow on more with division and exponents. So number one. So just a reminder, the rule that we're talking about is if you have x to the m power over x to the n power, you subtract the exponents when you divide, so that's the same as x to the m minus n power. So using that rule, 5 to the 8th over 5 to the 6th is 5 to the 8 minus 6, or 5 to the 2nd. 5 to the 2nd is 5 times 5, which is 25. Next one. It's always nice to deal with if you just have numbers, it's nice to deal with those first. And so 15 divided by 5 is 3 on the top. So we have 3, and then the x's, subtract the exponents, you get 6 minus 6. Well, you might have just seen that if you have an x to the 6 on the top and an x to the 6 on the bottom, those will all cancel out, leaving 1. And here's another way that happens, because you get 3 times x to the 0 power. And if you remember, anything to the 0 power is, hopefully you said 1. So that's just 3 times 1, which is 3. Problem number 3. We have 2 different bases, so we handle them kind of independently. We can subtract exponents for the 5s, and we can subtract exponents for the 3s. 5 to the 4 minus 2 times 3 to the 3 minus 2. That's 5 to the 2nd times 3 to the 1st. And we have numbers, so we can just go ahead and multiply all that out. 5 times 5 is 25. 25 times 3 is 75. Number 4. Okay, we have x's, we have y's, and we have z's, and there's only a z on the bottom. So we're going to handle the x's, so we do that by going x to the 8 minus 9. The y's are to the 4 minus 1, and that's over z, which just stays on the bottom. X to the 8 minus 9 is x to the negative 1, so we're going to have to deal with that negative. We'll do that next. Times y to the 3rd, and that's still over z. Now this x to the negative 1 needs to go to the bottom to get a positive exponent. The y to the 3rd and the z are fine where they are. So y to the 3rd stays. X goes to the bottom as x to the positive 1. And z still stays there. Everything has a positive exponent. Everything's happy. All right, number 5, we have a power of a power, so we're going to do that first with the parentheses. Remember, the rule is that this goes to each of these things. And when you have m to the 2nd to the 3rd, that's multiplication. So that's m to the 2 times 3, and then n to the 3rd. And we'll leave the m to the 4th n for the next step. So that's m to the 6th n to the 3rd over m to the 4th n. Now we can subtract exponents on the m's, so we get m to the 6th minus 4. Subtract exponents on the n's, and that's 3 minus 1. That's m squared n squared. And finally, number 6, we have x's and we have y's, so our x's will be x to the 5 minus negative 9, y to the negative 3 minus 1. 5 minus negative 9 is really the same as 5 plus a positive 9. That's keep it, switch it, change it, or same, opposite, opposite. So x to the 5 plus 9 is 14. Negative 3 minus 1 is negative 4, so y to the negative 4. Finally, we don't like that negative 4 exponent, so that's going to need to move to the bottom. So we have x to the 14th, which stays in the numerator, and y to the 4th.